Welcome to qnawire.
Here the question is, compounds of copper 2 are generally colored, but compounds of copper 1, copper plus 1 are not. Explain. Would you expect cadmium NH3,4 Cl2 to be colored? Explain. Now for this, first of all, we have to understand that why transition metal complexes or salts are generally colored. In case of compounds of transition metals, according to crystal field theory, d orbital splitting is taking place, and lower d orbitals are dxy, dyz, dxz, and upper d orbitals are dx square minus y square and dz square. This splitting of the d orbital is taking place, and these are having lower energy and this is higher energy. This and difference between these two is the delta E, which is needed for dd transition. So if from the lower energy level the electrons are excited to higher energy level, then delta E amount of energy is needed for the dd transition. Now, if the d orbitals are completely filled, there is no scope for the dd transition. So when the dd transition is not possible, the whole white light is reflected by the substance and the substance will appear white. Whereas if one place is left or there is scope some for the dd transition, then what happens that a part of the white light is absorbed by the substance and the remaining part is reflected, and that reflected part is received by the eye and the substance is appearing according to that color, that complementary color, which is reflected by the substance. Now, same theory is applicable in case of copper 2 plus, copper plus, and cadmium. So let us see, in case of copper, we know that its outer electronic configuration is 4s1 3d 10, and here it should be argon. So the copper plus should be argon. First electrons are removed from the 4s orbital, so it should be 4s0 3d10. And in case of copper 2 plus, the electronic configuration should be, after argon, 2 electrons are removed, first from the 4s orbital and then from 3d orbital. So 9 electrons are left in the d orbital. And in case of cadmium, it is after krypton, that is noble gas configuration, it should have 5s 1, 5s2, and 4d10. So this should be 2. Now, according to this electronic configuration, we have to understand which substance will be colored and which is not. In case of D10, electronic configuration is same as in the given example. And there is no question of DD transition because there is no place for the exciting electron to come, and that is why the whole white light is reflected by the substance, and these all complexes and their salts will be white in color. Whereas in this case, copper 2 plus, there is one scope for the DD transition because the electronic configuration is D9. So these are completely filled, but here one place is left, one unpaired electron, and here the DD transition is possible. When this DD transition is possible, a part of the white light is absorbed by the substance because this energy is falling in the visible part, and the remaining part is reflected by it, and that reflected part is received by our eye, and the substance will be colored. So in case of copper, as we know that copper 2 plus is colored, and that color is blue.